In this video, we're going to go over the Stream Reach and Catchments tool, the final tool in the Stream Network Development tool set. If you're on this third and final step of developing your perennial stream network, that means that you have delineated your flow network using either area threshold or the Puker-Douglas method, and that you have manually populated the stream type field in either of those networks. Previously, if you did not take the time to code your perennial network, then this tool would consider every single flow path a part of your stream reach, which is inappropriate. So previously, we had gone in and coded our perennial network using a value of 1. All other flow paths were given a value of 0. So when we run this tool, we'll be making a subselection saying only create the stream reach based on a stream type value of 1. And then we'll have an accurate stream reach. And this is going to be the feature class that we use in all future ACPF tools when a stream reach is asked for. Alrighty, so we're back in our map document. We've got our lovely stream network here where you can see I've symbolized it so I can see 1, my perennial network here in blue, and then I can see all those other ephemeral or intermittent or ditches there in 0 and this mintish green. So we have our flow network that's been edited. We can come over to the tool, double click to open it up, and we have 4 to 5 inputs. One is optional, as we'll see. The first one is asking for our flow network. That'll be this one that we've made edits to. Second is the flow direction roster. Next we have the filled DEM. Then it asks for our watershed boundary. We're going to make some sub-selection to base our stream reach on. And then the 5th optional input is our pour points. And we're going to get 2 outputs from this tool, our stream reach and then the catchments associated with those stream reach. So let's grab our area flow net, and if you made edits to your Puker-Douglas network, that's the one that you'll be putting in here. You can see our flow direction, our filled DEM, and our watershed boundary are automatically added. And now it's time to make that sub-selection that our stream reach will be based on. So we'll come down here, choose stream type, say I only want you to develop my stream reach based on values of 1. And then pour points, I will add my pour points, so I'll navigate to my file geodatabase, grab my pour points, there they are, just waiting for me. And then we can see our stream reach has been automatically populated, catchments are automatically populated, and then we have this third optional output, which is a new watershed boundary. This is going to be based on these catchments that get developed here. I am going to create it. It's optional, you don't have to, but I think it can be valuable to see how your watershed boundary has changed. So I'll just call it new BND, and as always, we'll end in our 12-digit HUC ID. Push save. So everything's good to go. We have our proper selection, and we'll hit OK and let it run. Similar to before, this tool uses tau DEM to run, so it's going to be running in the foreground. So before the tool finishes running, I just want to go over real quick what the output is going to look like. So you're going to get your stream reach, which is each of these individual stream segments, and then with each of those segments you're going to get a catchment associated with it. So, and they'll be related by the link no within the stream reach and then the grid code within the catchment output. So you can see in this highlighted area that each individual segment gets its own catchment, which in some cases ends up with these strange small little catchments that are in between segments. And that's alright, that's just the actual drainage area that's going to that segment. The catchments layer is valuable because it can reveal discrepancies between the old and new watershed boundary, which we'll see in a moment. Alright, so the tool is just finished running. I'm going to do some quick reorganization of my table of contents. I can turn off my area flow network. We can see I have this lovely stream reach put out now, which is exactly the same as the perennial stream network that I developed using my area flow network. We also have our new catchments output, which we can see here and back. And then if I turn that off real quick, you can see our new watershed boundary, which we'll take a closer look at in a second. So we'll go into the attribute table and take a look at the stream reach feature class. You can see we have a lot of fields associated with our stream reach feature class. Some of them will be very valuable. You can see we've got that drop value here and some slope. We have our segment length, our stream order for each segment, but probably the most valuable one when it comes to relating it to our catchments is the link number, which is a unique identifier for each stream segment. If we look at our catchments attribute table, we have a field called the grid code. These grid codes will match up with the link number seen in the stream reach attribute table. If we symbolize our catchments by categories and then by the grid code field and add all values, we can see all of our individual catchments, which there are quite a few, and in some areas you'll get some smaller ones. Let's see if we zoom in, move around, you can see right here you get this smaller orange watershed, which is associated with this one segment right here. It may seem kind of strange to break down the watershed like this, but it can just be valuable to understand where the flow is specifically going to which segment. Then we have our new watershed boundary. I'm going to make this hollow and make the border a brighter color so we can compare it to our old watershed boundary. And I'll make my old watershed boundary bright yellow. Okay. So these match up fairly well. There can be cases where your new watershed boundary is pretty different than your old one. And in that case, you may want to evaluate the new to the old, which one seems more appropriate, and see why there are differences between the two. But this one doesn't have too many differences going on. We do see that the new boundary seems to be more confined by this roadway here, but down here it became looser, you could say. And if you'll remember, when we edited our pour points, we kept the one furthest downstream so that this flow path right here would be included. If I turn on my flow accumulation roster, which remember I thresholded to 1,000 cells, which is approximately equal to 1 acre of contributing flow, we can see that now this flow path, which does appear to be a part of this flow network, is included in our watershed boundary, where it was not previously in this yellow watershed boundary. It may not seem like a big deal, but when you're running tools later on that are based on the flow accumulating to a certain part of the stream, this could have a big impact on your results. So this is why it's important to review your watershed boundaries and decide which one you'd want to use in later tools that ask for a boundary. So congratulations, you've officially developed your perennial stream network and can move on to start citing conservation practices within your watershed. You've finished all the big manual editing processes associated with hydroconditioning your DEM and developing this stream network, so be happy. From here on out, it's smooth sailing. And here is a brief recap of everything we just did to finally get our stream reach. And that stream reach is going to be the input for all future tools asking for a stream.